morning everyone. In today's class, we are going to learn about the important concept in probability, that is the multiplication theorem of probability. In our daily life, we deal with a situation where two or more events happen together. Like if we take a coin, if we take 2 coins, the probability of getting the chances are that we can get 2 heads if we toss a coin. And like that, if you take a deck of cards, probability of getting, if you take 2 cards from the deck, probability that card is probability of getting a card that king or queen. We can trying 2 cards from the deck and selecting students based on the multiple conditions are all these cases. In all these cases, we are interested in finding the probability of simultaneous occurrence of events, and the multiplication theorem tells us to calculate that exactly. And this multiplication theorem of probability tells that the written tells how to find the probability of 2 events, 2 or more events happening together. Let's assume that this is the probability of that event A and B happen together. We can write it as probability of A intersection of probability of event B. And what this multiplication theorem says is that the probability of A intersection of probability of B equal to probability of event A into probability of B given by A. Meaning that if we take two events A and B, the probability of 2 events A and B can happen together. If we take it in the multiplication theorem of probability, the same thing can be written as probability of A intersection of B equal to probability of A. Probability of A is the probability of A is that happens, and probability of B is that happens after the probability of A that already happened. And why do we need this probability? Why do we need this multiplication theorem of probability? Because the events changes. The event can be independent or the event can be dependent. So there are 2 kind of events that can happen. So let us discuss about the dependent event. Dependent event. Let us take a lesson with the example. If we take example like a deck of cards, and if we try to take one card from the, why do we need this is because the events can be dependent or independent. If we take an example of a deck of cards, and if we take one card of these total cards, and we do not change the do not replace the card, and the probability of getting the next card will be changes. So this is a dependent. This is dependent situation, and we can talk about the independent situation where this the probability of outcome do not depend on the change. So if we take a coin and a dice are thrown together, finding the so let's find the probability of getting a number and a head or tail for a coin. For suppose a coin let us take 1 coin and 1 dice, and let us try to find the probability of getting head per coin and probability of getting 4 per dice. So for a coin, what is the probability of getting head? There are only two sides of the coin, that is head and tail. So probability of getting a head is only 1. So we can write probability of getting head is 1. So the total number of outcomes are 2. This is for coin. And what is the outcome for the dice to get 4? Probability of getting 4 for die. For a dice, there are total 6 number of total outcomes, and the getting 4 for a dice, there is only one possible outcome for getting that number. So here also it is 1/6. So what we need to do here is, so this head and getting a head for a coin and getting the 4 for a dice are dependent event, which we can write it as 1/2 and 1/2. Let us take another example for a dependent event. Let us take example of take a bag, and there are 3 balls and 3 red balls and 2 blue balls. And from the bag, 2 balls are down without replacing the bag. And we need to find the probability of getting the red ball. First, what we can do is, we need to find the red ball. So probability of getting red ball. What we have, there are 3 red balls in a bag. There are 3 red balls, 2 blue balls. So we need to find the probability of getting red ball. That is, so what is the final outcome? There are total number of balls here is 5 balls. And we are talking about the red balls, so there are only 3 possible outcomes for the red. So what we have done, we took in, now we took 1 red ball out of the bag. So only here 2 red balls are there and 2 blue balls are there. So what will be the probability of red ball and probability of blue ball? Will be the total probability of this ball will be 2/4, because we remember the total possible outcomes will be 4. Now we can apply this multiplication theorem for this. What is the probability of getting red ball, intersection of getting blue ball, 3/5 and 2/4, which is 3/10. Here we are talking for the 2 events. In a bag, there are that contain red balls and blue balls. Now let us discuss for the events. For general form for the 3 events.
The probability of 3 events happening together is equal to the probability of first event multiplied by the probability of the second event given the first event, and then multiplied by the probability of the third event given that The first two events have already occurred.
Multiplication theorem derives from the equation of definition of conditional probability. We know that probability of B given by A equal to probability of A intersection of B by probability of A. And rearranging this, we can write probability of A intersection of B equal to probability of A into probability of B given by A. And probability of A intersection of B equal to probability of A into probability of B given by A. This equation can be used for the dependent event, and this is for condition. This is the equation for derived from the condition probability. Now let us know the general form for the three events. Let us say if we take the three events, probability of A, B and C, we can write probability of A into probability of B given by A into probability of C given by A intersection of B. Now we understood that. Now we know the equation for finding the probability for a dependent equation, dependent event, independent event, and this is the equation. This is the general form to find the probability for a three events. That is for a three events, probability of A intersection of B and B and intersection of C. So from this we can understand that this probability of simultaneous occurrence of two events, the probability of an event multiplied by the conditional probability of the second event given the first has occurred, and this is what the multiplication theorem of probability says. And